In this video, I am going to be covering the mathematical definition of a derivative. This method will give you the derivative of any function, any f of x that you can think of. So it's pretty cool. You're not going to use this method very often, and that's because it's kind of long, but most of your derivatives, in fact, almost all of them, you'll learn shortcuts for. This is just the kind of thing where you have to learn it at first because you're going to have some homework and you're going to have a test question or two on it. So we'll go ahead and learn this and we'll knock it out of the way, and that way we can get on to solving derivatives really quickly. One thing to note about this method is that it is almost all algebra. There are like 2 lines of calculus here, and the rest is algebra. And you know algebra, right? That's good news. So if you just go slowly, take your time, and be really careful, you'll get these problems every time. They're really not that bad. So I'm going to show you the formula. I'm going to give you a couple examples where we apply it in different ways, and then we're going to call it a day. Let's get started. All right, so the formula. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x divided by h. So this is just the limit. I know it looks a little scary, but just bear with me. We'll do some examples, and I promise you it'll make sense. So essentially, there are 4 steps to solving these problems. So the first step is you find f of x, which you'll be given, so that's really easy. Step 2 is you find f of x plus h. So you're just going to plug in x plus h everywhere you see an x. I'll explain. You'll see what I mean. Step 3, this is the long one, you do a lot of algebra. You have to be really, really careful because you're going to have negative signs and you have to make sure you distribute them. So a lot of algebra. And step 4 is you just solve the limit, right? You just plug in h at the end and you get your answer. So our first example, find f prime of x where f of x equals 3x squared minus x. Okay, well, how do we do this? First, let's write down our formula. The limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Okay, so step 1, right, is we look at f of x, and we know that. It gives it to us, right? F of x equals 3x squared minus x. And now we need f of x plus h, right, because that's step 2. So to do that, we just put x plus h everywhere where there's an x. So 3 times x plus h squared minus x plus h. And be careful, because a lot of times people forget to distribute the negative, right? So make sure you put your parentheses and are careful of that negative. So that gives us 3 times x squared plus 2xh plus h squared minus x minus h. And that ultimately simplifies to 3x squared plus 6xh plus 3h squared minus x minus h. And now we plug everything in. So f of x plus h, we put 3x squared plus 6xh plus 3h squared minus x minus h, minus f of x, which is minus 3x squared minus x. And now again, remember your parentheses. You got to be careful there because a lot of times people forget to distribute the negative, and so don't make that mistake. And all of that divided by h. And now we distribute the negative, and we get 3x squared plus 6xh plus 3h squared minus x minus h minus 3x squared plus x, all divided by h. And we notice we have a 3x squared and a minus 3x squared, so we cross those out, and we have a minus x and a plus x, so we cross those out. And now we rewrite this as the limit as h approaches 0 of 6xh plus 3h squared minus h, all divided by h. And now the h's cancel, so we get the limit as h approaches 0 of 6x plus 3h minus 1, and we can just plug in 0 for h, so we get 6x plus 3 times 0 minus 1, so we get that f prime of x equals 6x minus 1. Whew. Okay, so we did it. We solved our first derivative. And now, it's a little complicated, right? It looks like, oh man, there are x's and there are h's flying all over the place, but if you just take it slowly and just follow your nose, it will work out. Couple of things, right? So all we did is we plugged in x plus h everywhere we got x. We just expanded that out. That's just algebra, right? You know how to do that. You just have to be careful with your minuses. And then we plugged everything in, we subtracted, a lot of stuff canceled, and then we divided out that h, and we plugged in 0, right? That was it. So just a little secret, just between you and me, when you're doing these problems, that h in the denominator will always cancel. If it did not cancel, you messed up. You probably forgot to distribute a negative somewhere. So just that h will cancel. So that's a big red flag if you can't cancel out that h like we did in the last step. Let's do another example. This problem tells us to find the equation for the tangent line of the square root of x minus 4 at x equals 8. Now honestly, this problem is about as complicated as you're going to see in this unit. So if you understand what's going on in here and you can do it yourself, you're going to be good to go, right? So this is as tough as it gets. So I encourage you to try to solve this one on your own and then play the video and see how I solve it. So let's go ahead and dive right in. This problem looks a little bit different. We're not looking for the derivative exactly. We're looking for the equation of the tangent line, right? And so essentially we're looking for the equation of a line. And now if we think back to algebra and pre-algebra, what do we need to get the equation of a line? Well, there are two different ways to do that. The first way is we need 2 points, right? Any 2 points on the line, we can get the equation. Or we need any point on the line plus the slope. And now, since this is calculus and we're working with derivatives and slope of a tangent line, I bet you probably guessed that we're going to go with that second way. In calculus, our go-to form for a line is called the point-slope formula. And you've probably seen this before, but just as a reminder, the point-slope form is y minus y1 equals m times x minus x1. And m is the slope, and x1 comma y1 is any point on that line. So we just need the slope and any point, and we can plug them directly in here, and we're good to go. So we'll need to get both the slope and the point at some point. But let's start with the slope. Let's start with m. How can we calculate m? Well, this is the formula for the tangent line, right? And the slope of the tangent line is the derivative, right? Slope, tangent line, derivative, that should all be connecting in your head. So we need the derivative at x equals 8 because we want the tangent line at x equals 8, and the derivative is the slope of the tangent line there. So all we're going to do is take the derivative, plug in 8, and boom, we have m. So let's go ahead and start. As always, we start with our formula, right? The limit as h approaches 0 of f of x plus h minus f of x, all divided by h. All right? So we need f of x, which we have, the square root of x minus 4. We need f of x plus h, so we just plug in x plus h for x, and we get the square root of x plus h minus 4. Now we just plug everything in. The derivative then becomes the limit as h approaches 0 of the square root of x plus h minus 4 minus the square root of x minus 4, all divided by h. And now normally we can just kind of simplify the numerator a little bit, cancel out the h, and call it a day. But we can't do that here because the numerator is already as simplified as it can get. So what can we do? Okay, well it's a limit, so let's try solving the limit analytically. Okay, so first direct substitution, we plug in 0 for h. Can't do that because there's a 0 in the denominator. Can we do cancellation? That's plan B. Can't, there's nothing to factor, so can't do that. So on to plan C, which is rationalization. For rationalization, we just multiply by the conjugate divided by itself. And if you don't remember the conjugate, I'm only a little bit sad. So in this case, it is the square root of x plus h minus 4 plus the square root of x minus 4 divided by the square root of x plus h minus 4 plus the square root of x minus 4. And again, this is just a clever form of 1. So we're really just multiplying this limit by 1. And if all this is looking really strange to you, I encourage you to go back and watch my video on how to solve limits analytically. We go over this in a lot of depth. So when we multiply that through, we get x plus h minus 4 minus, in parentheses, x minus 4. Don't forget those parentheses. Those will burn you. And now with rationalization, we do not simplify the denominator. And we keep going and simplify this one more time. And we get x plus h minus 4 minus x plus 4, all divided by h times the square root of x plus h minus 4 plus the square root of x minus 4. And now we can cancel, right? We have the plus x, the minus x, the plus 4, the minus 4. And what do we have now? We can rewrite the derivative now as the limit as h approaches 0 of h divided by h times the square root of x plus h minus 4 plus the square root of x minus 4. In that h in the bottom and top, those cancel, and that gives us the limit as h approaches 0 of 1 over the square root of x plus h minus 4 plus the square root of x minus 4. And now we can finally plug that 0 in, right? We're always trying to go back to direct substitution with limits. So we plug in 0 for h, and we get 1 divided by the square root of x plus 0 minus 4 plus the square root of x minus 4. So that gives us 1 divided by 2 times the square root of x minus 4. Now, I know that one was kind of complicated and weird, but just go back over it. If you get stuck, just go back over it until you can get it all the way through and you really understand it and can do it on your own. It helps you, and honestly, it gives you more views. So hey, we both win. So now we have f prime of x. So now we plug in 8 to get the slope of the tangent line at x equals 8. So f prime of 8 equals 1 divided by 2 times the square root of 8 minus 4, which equals 1/4. So m is 1/4. And look at that. It turns out to be such a nice answer. It's almost like I did it on purpose. But we're not done yet. Because we're looking for the equation of the tangent line, not just the slope. So we have the slope, and now we need the point. So let me remind you of our point slope formula. Y minus y1 equals m times x minus x1. We have m. M is 1/4. And so what is our point? How do we get our point? Okay, so this is the way to think about this, and because you're going to see this kind of problem quite a bit in calculus, where you're looking for the equation of the tangent line. The tangent line touches the function at one point exactly. So there's one point on the tangent line, which is the exact same point on the function f of x, right? And that is at x equals 8, because that's where the tangent line is, right? That's specifically what we're looking for. So if we plug in 8 for f of x, that's going to give us the y value on the function. But also, because the tangent line, by definition, intersects the function at that point is also on our tangent line. So let's do that. So x1 is 8, and y1 is f of 8, which is the square root of 8 minus 4, or 2. So y1 equals 2. And now we just plug everything into the formula. So y minus 2 equals 1/4 times x minus 8. A lot of calculus teachers are totally fine with you leaving it in point slope form. But in case yours isn't, let's get it in y equals mx plus b. So we just multiply through and add the 2, and we get y equals x over 4. And we're happy because now we are finally done with this problem. Again, this problem is really as difficult as you're going to see. So I think it's worth stopping for a minute and thinking about what we did. We were asked to find the equation of the tangent line at x equals 8. And we said, okay, equation of a line, we're going to use the point slope formula because we're in calculus and that's kind of our go-to. So what's the point slope formula? Y minus y1 equals m times x minus x1. And what do we need? We need m, the slope, and we need 1 point x1 comma y1. It can be any point on the line, we just need 1. And n is the slope of the line, and since it's the tangent line, we know that the slope of the tangent line is the derivative. And since it's at x equals 8, we're looking for the derivative at 8, or f prime of 8. So we said, okay, well, we know how to find f prime of x. It is the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. So that gives us f of x, and then we plug in 8 to get m. So we're good on m. Now we just need our point x1, y1. And we know that the tangent line intersects the function at one point. And specifically, we know, since we're finding the tangent line at x equals 8, we know that the tangent line intersects the function at x equals 8. So okay, so since it intersects the function, that means that the y value of the function is going to be the y value of the tangent line, because that's what intersects means, right? They have that point in common. So to get our y value, we just plug in 8 to f of x, not to f prime of x, it's an easy mistake to make too, but to f of x. So y1 equals f of 8. And so then we got our y1, we had our x1, which was 8, we have our m from our derivative, and we plug everything in, and we get our answer. And now, finally, let's recap everything. So, the derivative. F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x, all divided by h. Okay, so how do you find the derivative? You first find f of x, well, that's probably given to you. You then find f of x plus h by plugging in x plus h everywhere where there's an x. And then you do a lot of very careful and very meticulous algebra. And then the h in the denominator will always cancel. If it did not cancel, you did something wrong. You probably forgot to distribute the negative for the minus f of x. So be careful. But it will always cancel. And then once it does, you plug in 0 for h, and you're done. You call it a day. That's all I got. I know that was a lot, but just go back, rewatch this video until you understand it. Again, helps you, it helps me. And it just, I promise, most of it is algebra, right? There are only a few steps of actual calculus in these problems. The hard part is algebra, and you know algebra. So don't get intimidated by this. Take your time, be careful, and just follow your nose and do the algebra carefully, and you'll be good. If you enjoyed this, found it helpful, leave a like, subscribe, share it with your friends, and I will keep the math content coming your way.